I will do a Thevenin's theorem example, a pretty simple one. So what I need to do for this circuit is I need to find the Thevenin's equivalent for 5 ohms. So basically, if I want to measure a current or a voltage across 5 ohms using let's say current through 5 ohms resistance or voltage drop across it, uh, and I will use Thevenin's theorem, what will I do? So basically what will I do? Thevenin's circuit as seen by 5 ohms. That means like we will use that one as the for which we need to find. So to find Thevenin's voltage, what we will do, we will disconnect it here. So the circuit will now become like this. So 10 ohms here, 10 ohms here, and 4 amps here. So what is the open circuit voltage in this case? Now since we have this one open, there is no source for current conduction, no path for current conduction in this direction, so the current here will be 0, that will be 0. So drop across this one, this 10 ohms resistance will be 0 as well. So V open circuit, which is here, will be just the drop across this 10 ohms resistance, and that will be, since this is a 4 ampere current source, the current will be 4, which will go just like that, current will flow like that, and the drop will be 10 times 4, that's 40 volts. So that is our VOC. Now we need to find the Thevenin's resistance. So we will look at this circuit. This one is open circuit, so basically we will have to uh, find the resistance looking from here. And since that one, what we will do with the source, if it were a voltage source we would have short circuited it, but this is a current source, so we will just take it away. It will be an open circuit here. So 10 ohms now, 10 ohms now. So R Thevenin's that can be seen from here, when we say resistance seen from here, is as if we have a source connected here. So what will be the what will the source experience as voltage, as resistance? So we can see these 10 ohms and these 10 ohms are coming in series. So the Thevenin's voltage, Thevenin's resistance R Thevenin will be 10 plus 10, 20 ohms. So we have now our circuit. So we can replace this entire part by voltage source, one voltage source which is Thevenin's voltage source, and this one is a resistance, and we will connect our resistance which is, for which we have found the Thevenin circuit, which is 5 ohms, and we calculated the Thevenin's voltage to be 40 volts and resistance to be 20 ohms. So this is our circuit. Now we can find 5 ohms here, the current through 5 ohms here. Let's do that actually. So we will see the current will be I5, let's say. So that will be 40 divided by 25. So it's 1.6 amps. So this is our resistance, current through the 5 ohms resistance using Thevenin's theorem. Now we can quickly check this problem by solving this problem by conventional method. So what I will do, I will quickly redraw the circuit here. So that's there, this is 10 ohms, this is like that, and this is there. So this is a very simple one where it may seem that Thevenin's theorem was not needed, but we have just done it as an example. There will be complicated problems where we will see Thevenin's theorem will make the problem easier to solve. So in this case, of course, the current I5 will be, we can apply current divider rule since we have two parallel paths. So that will be 4 here. The total one path is this one, another path is this one. So the resistance of one path is 10, another is 15, and the current through which the current that we are interested to find is this one, which is through the 15 ohms resistance, basically, because this one and this one, they're in series. So I will multiply by the other resistance, which is 10 here. So it is 40 divided by 25, which is 1.6 amps. So this is actually quicker this way, but I've just double checked, and as I said, there will be circuits where Thevenin's theorem will make the solution easier. So yeah.